Hey Geometry, let's go ahead and study for this Unit 5 test. So there's basically two parts of the test. The first part is about triangle congruence, and the second part is about triangle segments. So we'll take one at a time. Here's our triangle congruence review. Can you prove the triangle's congruent? Now here I know I have congruent vertical angles. Once I have two corresponding angles and one set of sides, I know I have angle, angle, side. So I'm going to say yes by angle, angle, side. All right, here's the one from the review today. Yes, because I know I have side, side, side. Let's take a look at this one. Now, if you need to draw these triangles separately, you can. If you need to draw them in different colors while they're overlapping, you can. And what I know I have here is this angle and this angle. And I have this side. I have this angle, but guess what? I also have that side through the reflexive property. So the answer is definitely yes. If I wanted to call it angle side angle, I could. If I wanted to call it side angle side, I could, depending on what it is that I'm using. If I use the reflexive property, then that side angle side works. All right, let's check this out. I know that I have a side here that is congruent to itself. It might be easier if you spin this one to the side and you look at these parallel lines. Now, my hint for drawing these parallel lines is always extend the sides and extend the transversal, because then it's easier for you to see alternating interior angles. So I have two angles and a side. The side is not in between the angles, so the answer to this one is yes, and it's going to be angle, angle, side. Angle, angle, side. All right, can you prove the triangle's congruent? This one's pretty easy. Yes, and we have side, angle, side congruence. All right, let's check out this one. I know that vertical angles are congruent, so I know I have one angle and two sides, but guess what? That angle is not the included angle, so this one I'm going to have to say no. Angle side side is not a congruence theorem or postulate that I can use. All right, let's check out this one. I have my parallel sides. I know I have my transversal. So if I look at my parallel sides, these here are my alternating interior angles. So I have an angle, and I have a side. So yes, by angle, angle, side. Okay, trying to think if I needed these two angles to be congruent. Could I have also done these two angles? I could have. And that would have again given me, you know what? I think those are the two angles I want, not these ones, because this is not an angle in this shape, is it? So the blue angles, these ones are the ones that I want. That's better now that I look at that, okay? So that's going to give me angle, angle, side. It's still angle, angle, side. Make sure you have the right angles. If it takes a little bit spinning the angles around, make sure you do that to double check. All right. I have the reflexive property, angle, angle, side. So yes, by angle, angle, side again. Here we go. I have a side. I have my parallel lines. I know these two lines are parallel. And I know here is my transversal. Make sure I get this one right. Here are my alternating interior angles. So this is going to give me angle, side, angle. All right. This one is kind of fun. I have my parallel lines. Here is my transversal. So what I actually have here are corresponding angles. Those two angles are corresponding. So again, I have yes, and I have angle, side, angle, angle, side, angle. Okay. Well, let's see how we do with the next page. This one's going to be a no, because an angle and two sides is not a congruence postulate. This one's going to be no, and this is not enough information. Only one angle and one side, not going to do it for me. This one, oh, I have to keep on reading this. Hold on. What additional information do you need to prove side angle side? To answer this question, you need angle T and angle U. I need to know that angle T is congruent to angle U. Nope. Angle V. I like that better, because it has to be the included angle. It's got to be angle V. What additional information do you need to prove side angle side? I'm going to need that segment LG. Make sure I get my order right here. Segment LG is congruent to segment MN. Now we're cracking. What additional information do you need to prove angle side angle? I need T and Q. I need to know that angle T is congruent to angle Q. What additional information do I need to prove angle side angle? I need, is this a repeat? Here I have my two sides, and here I need angle side angle. So angle side angle, I can have angle T and angle U again. I need to know that angle T is congruent. Uh-oh, did I get the wrong one again? Yep, I did it again. And this will give me angle side angle to angle V. I need angle T congruent to angle V. Boy, that one got me twice. I hope I don't put that one on the test, because that's definitely a tricky one. All right. X is the midpoint of A and G. Of AG, here's A to G, which means these two are congruent. X is the midpoint of NR. So prove triangle ANX is congruent. All right, so I have X is midpoint. And I know that that is given. So that means that it's the midpoint of AG and NR. So that means that AX is congruent to XG, and that's the definition of midpoint. I know that NX is congruent to XR, and that's also the definition of midpoint. I know angle AXN is congruent to angle GXR. And those are because they are vertical angles. So I'll put my fifth reason down here. I know that triangle ANX is congruent to triangle GRX, and that reasoning is they have side angle side congruence. That was a little messy. Let's go ahead and see if we can keep this one a little neater. GK bisects, so by definition those two angles are the same. And JG and GM are going to be congruent. So I have GK bisects angle JGM, and that is going to be my given. I know that segment GJ is congruent to GM, and that is also given. I know that GK is congruent to itself, and that is my reflexive. So therefore, I know that triangle GJK is congruent to triangle GMK, and that reasoning is side angle side. Oh, you know what I forgot? Here's my side that's the same, that's given. I have my reflexive, but guess what I need to put up in here? I forgot to say that the measure of angle JGK is going to be equal to the measure of angle MGK. And that is going to be my definition of angle bisector. Okay. All right. Let's get a Post-it note and see if we can keep the proof a little neater for this one. Ready? Let's try it this way. Ready? When I have segment AB is perpendicular to segment CM, I have segment AB is perpendicular to segment DB, and I have CM is congruent to DB, and that is all given. Here are my statements. Here's my justifications. So much for being neater, right? All right. Number 2. What do I know? I know that because this is perpendicular, I know that angle B and angle CMA are right angles, and that is my definition of perpendicular. So I know that angle B is congruent to angle CMA because all right angles are congruent. Okay, if I know that M is the midpoint, oh, I forgot that up here. M is midpoint of AB. If M is the midpoint, then I know those two segments are congruent to each other. So I know that AM is congruent to MB. AM is congruent to MB, and that is my definition of midpoint. So it looks like I have triangle AMC is congruent to triangle MBD, and why is that true? Because of side, angle, side congruence. Sound okay? That's going to be this one. Now we have one more proof to do. You ready? We'll put a new Post-it note over it. And we'll have our statements and our justifications. All right, I have segment FG is parallel to segment KL. Segment FG is congruent to segment KL. Awesome. Here they are parallel, and here they are congruent. I love it. Okay, I got to prove that the triangles are congruent. So here was my given. All right. If I know that these two are parallel, then I know that, again, if it's easier, extend your parallel lines. Get them right. Extend your transversal. And then you can see, oh, these are my alternating interior angles. So I know that, I'll put this down here. Angle GFK and angle LKF, I know that they are congruent. How do I know that they are congruent? Because they are alternating interior angles. If the lines are parallel, then I have these cool relationships. I don't need the converse. I'm good there. I know that segment FK is congruent to segment FK. That is my reflexive property of congruence. And when I look at my triangles, do I have them spun around? Yeah, I do. So I need to also say that segment FK is congruent to segment KF, and that is that symmetric property of congruence. All right, here we go, the big granddaddy statement of them all. I have side angle side, right? So I know that, watch your lettering here, triangle FGK is going to be congruent to triangle KLF. And the reason I know that's true is, again, side angle side congruence. Hey, they were all side angle side. Here's side angle side. This one was side angle side because I had M as the midpoint. Here I have side angle side because I had those vertical angles. And here I had side angle side because of the bisectors. Crazy. Side angle side kind of day. All right, that's it for, oops. Here's, that's it for that page. Let's keep going. Given AE and BD bisect each other, prove the triangles are congruent. So again, I have vertical angles. If AE and BD bisect each other, that means these two segments are congruent and these two segments are congruent. So again, you have side angle side congruence, definition of bisector. All right, solve for x and y. I know these two x's are equal to each other because this says it's bisecting. Okay, so if these two sides are congruent, that means that these two angles are congruent, so this is also 52. So 52 plus 52 is 104. And 104 subtracted from 180 sounds like 76. 76 divided by 2 is going to give me my value for x, because this whole has a value of 76. When I divide it in 2, that sounds like 38. Therefore, x is equal to 38 degrees, or 38. If these angles are bisected and these are the same length and these are the same, then that means that these two triangles are the same. This ends up being an isosceles triangle. This ends up being an angle bisector. It ends up being a median. It ends up being a perpendicular bisector. So I know that y also has a value of 4. Think about what this line segment is. This one line segment, I know it's an altitude because it comes from the vertex down. Because I know these two triangles these two sides are congruent through CPCTC. I know that it is a perpendicular bisector. Because these are the same and it goes up to the vertex, I know it's a median. Because it bisects that angle, it's an angle bisector. This triangle is isosceles, so each of those points of concurrency is going to lay on that line. Remember that from the video. All right, let's take a look at this one. Given AE is congruent to DE. Uh-oh. Do you think E goes up here? AE is congruent to DE. We're going to say yes, that's true. D goes, or E goes up there. AB is congruent to DC. Prove triangle ABE. Here's ABE. Is congruent to triangle DCE. All right. So here's how we're going to go about this one. You're going to give me your given, and then you're going to use the isosceles base angles theorem. So with the base angle theorem, you're going to go ahead and prove angle A and D are congruent. And then that again is going to give you side angle side. Boy, side angle side is the theorem of the day. Can you prove these triangles are congruent? We're going to say no, because their corresponding sides do not have the same measure. This is a hypotenuse opposite the right angle. And this can't also be 13, because this side's 13. It's not going to be isosceles because it has this right angle. So we're going to say nope. What values for x and y will make the triangles congruent? All right, I need 13 to equal 4x plus 1. So 12 is equal to 4x. X is equal to 3. So if x is equal to 3, 2x plus y has to be equal to 8 times 3 minus 2y. So 6 plus y has to equal to 24 minus 2y. Bring it up here to finish. Add 2y to each side becomes 3y. Subtract 6 from each side becomes 18. Y is equal to 6. So therefore, if x is equal to 3 and y is equal to 6, the triangles are congruent. All right. We got another one to go. These two have to be the same. So 2x plus 1 has to be equal to x plus 3. X has to be equal to 2. All right. So if I have 2 plus y has to be equal to 3 times 2 minus 3y. Bring that up over here. 2 plus y has to equal to 6 minus 3y. I'm going to add 3y to each side. I'm going to subtract 2 from each side, and y is equal to 1. Therefore, if x is equal to 2 and y is equal to 1, the triangles are congruent. What information do you need to prove hypotenuse leg congruence? You need to know this is a right angle. Because here's my hypotenuse, here's my leg, but unless these are right angles, I can't use hypotenuse leg. Got to have a right angle. What information do you need to prove hypotenuse leg congruence? I got my right angle. I need the hypotenuse to be the same, and I already have one leg, so I'm good there. But I need to know hypotenuse. Are congruent. All right, what information do you need to prove congruence? I have a side, I have a side, I have a side. I need another angle. So I need any angle will do. Any angle will do. Or if I have another side, either of those will work for me. Maybe if I knew that M and T, so R angle M and angle T right angles. I know it doesn't look it from the picture, but if they were, then I could use hypotenuse leg. So, all right. If AD is parallel to BC, can I prove congruence? Let's see. If these two lines are parallel, and if this was a transversal, that would give me this angle and this angle. And that would give me this side. So I'd have angle, side, side. Nope. Because those two being parallel gives me angle, side, side, but it doesn't tell me anything about any of my other angles. So I have to say no. Not enough information.